Welcome to myprojectbazaar.com. Our product title is Modeling, Modulation and Control of the 3-base 4-switch PWM rectifier under balanced voltage. Let us see about abstract of our product. In this proposed implementation is modeling, modulation and control of the 3-base 4-switch PWM rectifier, a general space vector pulse width modulation method for control of 4-switch 3-base rectifier is used in this implementation. The proposed vector PWM offers a simple method to select 3 or 4 vectors that effectively synthesize the desired output voltage, even in presence of voltage oscillation across the two DC link capacitors. The method utilized that so-called space vector modulation and includes its scalar version. Different vector combinations are combined in this implementation. The effect of star and delta motor winding connections over the pulse width modulator is also considered. The common mode voltage generated by 4-switch 3-base converter is evaluated and compared to the provided by the standard 6-switch 3-base rectifier. Then the high frequency model for the current ripple analysis is proposed in this implementation, and the effects of 3 space vector modulation approaches on the AC current ripple and also voltage harmonics. According to the analytical result, the method introducing the small current ripple is selected with the optimized space vector modulation approach, a control oriented model considering the capacitor voltage oscillation and deviations in build the DQ synchronous frames to facilitate the controller design. Furthermore, a control strategy implemented in this overall implementation. Next we see about flow diagram of our product. This is our flow diagram. In this flow diagram, the input is a AC supply. That AC supply is fed into a 3-base 4-switch rectifier source. That also is through the passive elements. That passive elements is nothing but inductors. After that, that rectifier output is fed into resistive load through a load side capacitor. That load side capacitor is act as a 1 base. Then the 3-base 4-switch rectifier pulses is getting from the space vector pulse width modulation technique, and it's delivered from the PWM generator. After that, main advantages of this 3-base 4-switch rectifier is compared to the conventional 6-switch rectifier, the overall switching count is reduced, and also it a bidirectional power flow and low harmonic distortions of line current, and it regulate the input power factor to unity and adjust the stabilization of DC link voltage and also reduce the filtering capacitor size. Generally, the space vector pulse width modulation has been proposed as a switching schemes for these converters. The simulation output is compared with 6 switches PWM converter that result show the higher output voltage obtained in the 4-switch PWM converter when compared to conventional methods, and also it proves that the 4 switches with the proposed switching schemes function successfully to the real-time controller, and also it's used to real-time control of power electronic converter constraints, which is widely used in industries. For also it using for the induction motor control, and also it driver with the induction motor and other kind of AC motors. Next we see about running process of our product. In this proposed implementation is done in Matlab simulating environment. First open the Matlab window and create the new model file. After creating the new model file, we arrange the elements as per the circuit diagram. After that, we click the run symbol in this corresponding creating model file. After clicking that, the corresponding output data will be shown in the corresponding connected scopes. The first one is input voltage 3-base voltage, and next one is a input 3-base current, and next one is a control signal is getting from the space vector pulse width modulation technique. After that, this is a capacitor 1 voltage that is connected in the load side, and next one is the capacitor current in load side, and next one is the capacitor 2 voltage waveform, and next one is capacitor current C2 current waveform, and the next one, this is the output current waveform in the variable DC manner. Next one, the output voltage waveform in the variable voltage. Next one, this is a fixed DC that is converted to variable to fixed DC. So this is a fixed DC voltage waveform. This is rising time, and after some duration it will be goes to constant value. So the overall harmonics is reduced in the input side, so overall efficiency will be increased. Thank you for watching this video.